Okay, so in the next couple of videos, let's go over some decision analysis applications. And specifically, let's talk about litigation decisions, then the principal agent problem, and product development sequencing problem, and a market research problem. So those are typical applications of decision analysis, and along the way we will introduce some new concepts like risk aversion or also the Bayes theory that is related to updating of preferences. But let's start relatively simple and first talk about a litigation process. And here you see a typical problem. So assume that you are confronted with a situation where you are being sued, for example, and you can either settle or you can litigate. And if you litigate, the case can be either heard or the case can be dismissed. If you litigate and the case is dismissed, you lose $3,000. If you litigate and the case is heard, then again two events might happen, which is that you can either lose the case or you can win the case. If the case is heard and you lose the case, you lose $63,000. And if you win the case, after the case is heard, you lose only $13,000. So in this case, we have a decision tree, and in the basic problem, what is unique about this decision tree is that we have here a chance node. So this is a chance node, and we have another chance node, which is here. So whenever we have two chance nodes in a row, what we can do is we can actually just multiply through the probabilities and combine the two sequential chances into one. So here the basic problem can be simplified by saying, you know, if you litigate, what might happen is that the case is heard and you lose. And that has now a probability of 0.6, which is 2/3 of 0.9. So 0.9 times 2/3, that's 0.6. What also can happen is that you litigate and the case is heard and you win the case. So that is 0.9 times 1/3. So now we have here 0.3. And this still stays the same, so you can either litigate and the case is dismissed. So in here, these are the probabilities. And you see the point here that's important is whenever you have two chance nodes in a row, you can just multiply the corresponding probabilities and you can simplify the decision tree. Okay, so now let's take a look at what the best decision should be. And what we need to do is we need to compare the expected payoff of litigation and then basically identify at what value you would settle. So let's first calculate what can you expect from litigation. I have already written down it here. So the expected value of litigation is that you lose with a probability of 0.6, 63,000. And plus with a probability of 0.3, you lose 13,000. And with a probability of 0.1, you lose 3,000. So if you sum that up, you can expect to lose 42,000 if you litigate. So in other words, you would settle for anything which is less than 42,000. So if you get a settlement offer, for example, 41,999, well, that is still better than expecting a loss of 42,000 from litigation. Okay, but now we have an important aspect to consider, which is that we assume risk neutrality. And that is often a very unrealistic assumption, and a more realistic assumption is to assume risk aversion. And if you're actually risk averse, you would settle for a higher amount. And in the next video, I want to introduce risk aversion into the decision tree of the litigation process. But before we go into details, I want to first say a couple of words about what risk aversion is and how it differs from risk neutrality. Okay, so I'll just stop here and then let's have a new video on incorporating risk aversion into decision analysis.